Hi and Assalamualaikum. My name is Nazrin Auladi binti Marashdi. My matric card number is 01G20F3013. So, our group will present about remote sensing, group yield estimation and agricultural vulnerability assessment. So, without further ado, let's get started. Now, I will present part of introduction. Agriculture system constitute a vital economic sector in rural Canada and worldwide. Sustainable rural systems are very much dependent upon the healthy development of agriculture. As a multifaceted bicycle and socio-economic system, the agriculture system is heavily affected by variation and change in the climate condition. Extreme climatic events such as severe drought can often cause devastating damage to agriculture and consequently to rural communities. The research attempt to investigate the relationship between agricultural production and the occurrence of the meteorological drought over time, and consequently to examine how sensitive and vulnerability agricultural production is given the variability in climate conditions in southern Alberta. A remote sensing approach will be developed to estimate the yield of a cereal crop in the selected years based on remotely sensed data in the study area. The yield estimate based on the remote sensing approach will provide a primary data to measure agricultural well-being and quantify agricultural vulnerability to drought. So now, I will pass to the next presenter, Ain Afika, to present her part.
Thank you, Nasrin. Hi, my name is Nur Ain Afika binti Zainal Azhari and my matric card is 01D020F2015. Now I will present about the study area and data. So, this study area is concerned with agricultural production in Southern Alberta. The spatial extent of the Landsat TM since define the boundary of the actual study area within which agriculture vulnerable assessment is conducted using remotely sensed data. This area represents the majority of agricultural region in Southern Alberta. Crop production and livestock are two dominants with an average farm size of 970 acres. The dominant crops in the study area include wheat, barley, oats and rye. During the past decade, Alberta produced 28% of the nation's wheat crop, and 44% of the barley and 23% of the oats. To assess agricultural vulnerability to drought at a detailed level, remotely sensed imageries are employed in the empirical analysis. Since multi-day satellite imagery can often generate superior land use and cover classification accuracy, and consequently generate better year estimation, two Landsat TM images for each selected year are acquired. The determination of image date is mainly restricted by data availability by first, the temporal resolution. The time between two overpass date for a particular location of Landsat satellite sensor is 16 days. Next, large cloud coverage prevents some image from being usable. The study area is defined as the overlapping area covered by all 6 acquired Landsat TM. Each of the optic imageries contains 7 spectral bands of information. 6 bands include in band 1, band 2, band 3, band 4, band 5 and also band 7. It has a spatial resolution of 30 meters for each spectral pixel, and one thermal band, which is band 6, has a spatial resolution of 60 meters, which is excluded in the image of analysis.
My name is Muhammadin Haikazan Abidin. My matrix number 01DGU20F2023. So I will explain about the method. The quantitative method for assessing the vulnerability developed by the Lewis et al. 2003 is adopted to assess the agricultural vulnerability to drought in the southern Alberta. Vulnerability is defined as a function of 3 components: sensitivity, well-being, stat relative, and to each demand threshold and exposure. Vulnerability of the agriculture system was calculated as you can see in the slide. There's formula about on how to calculate the vulnerability of the agriculture systems, where VI is the vulnerability value for specific year at a pixel, SI is the system sensitivity, YI is the crop yield in the year of interest 1998, 1999 and 2001 Y0 is the average crop yield over the selected years 1998, 1999 and 2001, and EI is the system exposure to stress. Okay, for the next slide. The sensitivity of the crop production is defined as the change in the system well-being, corresponding to a small change in stress. It is measured as the slope of regressing crop yield against the standard precipitation index (SPI) value. The calculation of the SPI first requires fitting the long-term precipitation record for the interesting location into an approximate probability density function. This function is the transform into a normal distribution so that the mean of the distribution is 0. SPI value above 0 indicate wetter periods and value less than 0 indicate drier periods. The monthly precipitation data during the growing season between May to August for a period of 1964 to 2004 were used to derive the value of SPI for all Environment Canada weather stations within the study area. The exposure is the frequency of the occurrence that the stress is below a threshold level. It is measured by the frequency of occurrence that the value of standard precipitation max was derived using the remote sensing data. Two Landsat images, one early and one late growing season for 1998, 1999 and 2001 were used to calculate NDVI. The relationship between NDVI value and the farm reported crop yield was modeled using the regression analysis. The regression coefficients were then employed to estimate crop yields at the pixel level, as shown in the figure 2. Present the methodological procedure employed in this study. As the result, based on the developed methodological procedure, the imageries from each year were first classified to identify the crop type using a supervised classification method. The overall classification accuracy are 86.4% in 1998, 83.7% in 1999, and 81% in 2001. Because the serial crop years are used as a measure of agricultural well-being, in the following agricultural vulnerability assessment, a relatively high classification user accuracy of cereal crop classes is needed. The user accuracy for the cereal crop class are 94.7% in 1998, 92.7% in 1999, and 89.8% in 2001. So, this is example of the flowchart on how methodological procedure for agriculture vulnerability assessment. As you can see, in table 1, present in detail the pixel percentile distribution of crop yield estimation accuracy in 1998, 1999, and 2001 using the derived regression model. Overall, the 1999 crop model performed the best with the median accuracy of 83.7%, while the 2001 regression model is the least accurate one with a median accuracy of 76.6%. So here, this is example of picture spatial distribution of estimate cereal crop yield in 1998, 1999 and 2001.
Hi, Assalamualaikum. My name is Nur Akmal Fasihah binti Ishaq and my matrix number is 01DGU20F2014. So I will continue the presentation, which is about estimated sensitivity of crop yields. What is sensitivity of crop yields? It stands for point data at the centroid location of the quarter section, and it also interpolated to generate a continuous surface representation of crop production. There are spatial distribution of sensitivity in which is presented on figure 7, and there are also descriptive statistics for each sensitivity class are presented in table 3. Let's go detail. Okay, over 30% of the study area has a sensitivity value less than 50. Most of the area with a low sensitivity are located within or close to irrigation districts. Nevertheless, there are some areas within irrigation district that are estimated more sensitivity than it's expected. This is because the total of this is because not all agricultural land within irrigation district is actually irrigated. every year. For example, the total area of a irrigation district east of Calgary is about 500,000 acres, within which is 95,000 acres are contracted on the water roll, and only less than 55,000 acres actually requested for irrigation surface in 2004. The southwest corner of the study area also has a low value of sensitivity. This is mostly non-agriculture areas within mountains and hills. Slight and moderate sensitive area are at central longitude areas and the southeast of the study areas. These two classes cover about 44% of the study area. Most of the central east and northeast area are classified as having a high to extremely high sensitivity. About 9% of the study area are associated with an extremely high sensitivity value, and a small portion of the study area is associated with a negative sensitivity value. So in this area, agriculture production is more sensitivity in the extremely wet condition rather than the extreme dry condition might be. Due to the orientation and scope of this study, agricultural vulnerability to the extremely wet condition will not be discussed. Okay, let's continue about crop production vulnerability to drought. Assuming that 1998, 1999 and 2001 can be considered as representative crop growth years, which is on figure 8 that presents the spatial pattern of production vulnerability using the 3 years average of vulnerability. On that average, over the selected 3 years, almost 35% of the study area was associated with a low vulnerability without considering exposure. There are areas with a low vulnerability was where a low sensitivity estimated. The area with a slight to moderate vulnerability value accounted for 55.7% of the study area. They were mainly located in the central part of the area, which is a total of 13.58% of study area was estimates with a high to extremely high vulnerability on table 4. They are also given the fact that moderate drought might be harmful among the cause-serve damage to cereal crop production vulnerability to moderate the meteorological drought in the study area over a long run is assessed. The exposure to a moderate meteorological drought condition is calculated as the proportion of the year with the SPR value less than 1.0 during the period of 1965 to 2004. The spatial distribution of the exposure is presented in figure 9. In the study area, at least 4 growing seasons were considered to be moderately dry during the period of 1965 to 2004. Over 80% of the study area experienced 6 to 8 moderately dry growing seasons. The highest exposure to moderate meteorological drought was 10 out of 40 years. Based on figure 11, there are expected agricultural vulnerability to serve the meteorological drought. There are the spatial distribution of crop production vulnerability to the moderate meteorological drought condition that present in figure 10, and also they have descriptive statistics presented in table 5. As you can see, a larger area was estimated as a very vulnerable due to the higher occurrence of the moderate meteorological drought condition in the study area. There are a total of 46.92% of the study area was considered highly or extremely highly vulnerable to the moderate drought condition, and particularly in the places outside of the irrigation districts. There are only about a quarter of the study area was not vulnerable, and most of which was within the boundary of irrigation districts. By given the increasing intensity of recent drought occurrence from 1990 to 2004, it is expected that the drought occurrence might be expected to be more frequent in the near future. Based on figure 11, they are present the expected vulnerability of coffee production to the extreme drought condition is if the recent drought frequency take place in the near future. About half of the study area is expected to be associated, which is with a high to extremely vulnerability. In the south part of the study area in the vicinity of Lusberg is expected to be very vulnerable to increased drought events. It is near feature of the enhanced adaptive capacity in the irrigation districts. Not only is the current agricultural vulnerability in the district relative low, but there are also agriculture production is expected to be less vulnerable to the drought condition, even if the propensity of the drought increase in the near future. That's all from me. I will pass to the next presenter.
Now I will present about conclusion. The conclusion for this presentation is assessing agriculture vulnerability is fundamental to understand interaction between agriculture system and the external stresses, including climatic conditions. In this study, an existing analytical method to quantify vulnerability is adopted to assess the magnitude as well as the spatial pattern of agricultural vulnerability to drought conditions in the southern Alberta. Overall, the region investigated in this study were susceptible to varying degrees of agricultural vulnerability to drought conditions. Empirically, this study generates some valuable insight into the extent and spatial variation of the agricultural vulnerability to drought conditions in southern Alberta. First, and the findings from this research indicate that there is sharp contrast in agricultural vulnerability to drought between irrigated districts and non-irrigated areas, while non-irrigated areas are vulnerable to varying drought conditions. Irrigated agricultural areas are largely insensitive to drought. Such findings confirm the importance of irrigation practice in the regions. The installation of irrigation system in the region has significantly elevated the adaptive capacity of the agriculture system to cope with the drought-related disturbance in the study area. Overall, a large area is quite vulnerable to the moderate level drought. Also, the moderate drought may not cause as a devastating effect to agricultural production as caused by severe drought. It can still result in obvious reduction in crop yields in the region. So that's all from us. Thank you, and to pay attention for our video.